Hello students, today we are going to be talking about solving absolute value inequalities. Okay, the part I'm going to show you is you have a definition. Okay, first let's return to the original definition of absolute value. So say if you have absolute value of x, this means the distance of x from 0. For instance, both -2 and 2 are 2 units away from 0. As you can see in the image right here, right? 0 in the middle, and then you have 2 units away. So to the right, we have +2. And then to the left of 0, we have another 2 units. So it's going to be a -2 though, because it's to the left of 0. Okay? So this means that absolute values will both be 2. In other words, we have absolute value of -2 equals absolute value of +2 equal to 2. And this equal the distance from 0. Okay, distance of 2 from 0. Okay, so that is the definition. With this definition and picture in mind, we are going to be looking at some of the absolute value inequalities. Okay, so first let's take a look at this example. So case number 1 is the less than or equal to. If you have absolute value of x less than 4. In this inequalities, they're asking me to find all the x value that are less than 4 units away from 0 in either direction, right? Because earlier we see 0 to the left, 0 to the right have the same distance. Yeah? So it has to be less than 4 units away from 0. With that being said, it have to be between the -4 and 4, isn't it? So we're gonna look at some example. For example, we have 2. It's 2 units that less than 4, right? From 0 right here, if we jumped into 2, that's 2 units. And if you go to the left 2 unit, it's also is gonna give us the distance of 2. So both 2 and -2 will give you the distance at less than 4. So does 3 and -3. Yeah. 1 and -1 also give you the distance from 0 to that number is still less than 4. So 3.99 will also works. -3.99 would definitely works. It's still less than 4 units away from 0, right? However, -4 wouldn't work right here because the absolute value of -4, that means is 4, isn't it? And 4 cannot be less than 4. It can only be equal to 4. So it doesn't take the 4 right here. So we're going to use an open circle, okay? So to indicate that it's not included. Same thing over here. We're going to be using an open circle. But since all of these values can ranges between -4 and 4, we are going to be shading between the -4 and 4. Okay, so on the graph, it looks like this. Open circle, and then x in the middle, and then another open circle with -4 and 4 in mind. Like that. Algebraically, because x is between those two values, we're going to put x between -4 and 4. So -4 less than x less than 4. Okay? -4 less than x less than 4. All right, so let's take a look at this general pattern that we can generate from this. Okay, so we have the pattern for less than absolute value inequalities always hold. Given an inequality in the form of absolute value of x less than a, then the solution will always be in the form of -a less than x less than a. In other words, x is between the -a and a. Okay, a can be any numbers in the world. Let's take a look at the first two examples right here. Now, example 2, part A. We are asked to solve x plus 6 less than 2. Okay, so x plus 6 less than 2. So let's think about this. X plus 6 less than 2, what it means is you are going to have the value of x plus 6 have to be between negative 2 and 2, right? It have to be less than 2 from 0. So we are going to go ahead and grab this one. Yeah. In other words, is what it means, like x plus 6 have to be between the negative 2 and 2. Right, so we're gonna grab this one and we're going to see on the graph how the graph is gonna look like, where it is shaded. Okay, the part where it's shaded, that means that is the solution. So let us take a look. On the graph right here, ladies and gentlemen, we are going to take a look at how the graph looks like. Okay, now the tip for you that whenever you're trying to grab it, if you put the y plus in the front, it will show the whole graph, the whole entire graph. Okay, so we are going to graph like normal equation, but this time we're gonna put the y plus in the front. Okay, in other words, if you put plus y, it works the same way. All right, so let us take a look. We are going to put in absolute value. So you find the absolute value right here above the ABC. Okay, above the ABC. You're gonna type it in. Let's see the equation. X plus 6 less than 2. So absolute value inside, it's gonna be x plus 6. And then can you come outside and say less than 2? Boom. So as you can see, your graph is kind of pointing down like this, but it's crossing your x. That's all matters, okay? So you see your graph is looking like this, and it crossing your x-axis at negative 8 and 4, and the graph is looking like it's being shaded, right? It's being shaded in the middle, like right here, right here, right here. It's being shaded right there in the middle. So we say the x is between negative 8 and negative 4. Okay, x is between negative 8 and negative 4. And this is the dotted graph. Do you see that? The lines on the border is dotted because we don't have the equals right here on the inequalities. We only have that one. So back to the problem, back to the assignment right here. Let me clear out this one. We are going to grab the solution. Okay. This one is mean the open dot. So we're gonna put the open dot. So just like on the graph, it's shaded in the middle. We are going to be shaded in the middle like this. And then we put the two number that the graph is crossing by, right? Or the x-intercept. We have the first one is negative 8. And the second one is negative 4. Right? Those two in the middle right there. It's shaded between. Right? Shaded between negative 8 and negative 4. So we're going to put negative 4 on the right side. And to represent your answer, think about it's shaded between mean in the middle, right? So you put x in between the two values, in the middle of two values. Just exactly how the graph looks right here. We're going to put negative 8 less than x less than negative 4. And we have the open circle on the two values. It's not included at negative 8 and negative 4. You can take any numbers in between, okay? Negative 7, negative 6, negative 5. Negative 6, I can be negative 5, it can be negative 4.999999, and so on and so on. Okay, here you go. So some value for x. Of course, if they don't ask, we don't have to list them. Next, we taking a look at the second example. So this one, the only thing that's different is we have the 3x minus 6. Inside the absolute value, the number is different. And then right here, we have the less than or equal to 15. So less than or equal to, remember, we are going to be using the closed dot on the answer choice, okay? So we're going to be using closed dot whenever we represent our answer on the number line. Now we're going to go ahead and grab this one, just like how we grabbed earlier. Remember to see the whole graph, we're gonna put y plus in the front of everything else, okay? So put y plus and then absolute value 3x, okay, y plus absolute value again in the bottom on the keypad on absolute value of a, and then you type in exactly how it looks like. 3x minus 6 less than or equal 15. 3x minus 6 inside. Oh, my button is right here. 3x minus 6. And then you go outside and then you put exactly how it looks. Less than or equal 15. Boom. Again, as you can see, the graph are shaded in between. So again, we're looking at the x-axis, right? So find out the x-intercepts and then see where it's shaded. You can mark them where it's shaded. So as you can see right here, they are shaded in the middle. So from here to here, you see, it's shaded. Everything in there is shaded. That means it take all the value in the shaded parts. So the two number that we're looking at right now is going to be -3 and 7. So the x is between -3 and 7. Okay, so let's go ahead and copy our graph. And then we're going to write out the final answer. Remember, this one is a closed dot because of the absolute value. The inequality sign is less than or equal, so we're going to be using closed dot, closed dot. The two numbers, of course, let me show you again. It looks like this. On the x-axis, the x-intercept or the 0 is -3. To the right is +7. So put -3 and +7 here. Because it's shaded in the middle, we are going to be also shaded in the middle. Let's write our answer. Our answer algebraically is going to represent your x got between the two numbers, -3 and 7. And of course, because this one less than or equal to, it's going to match on your answer, okay? You have to match with the same sign. So here we have both of them are less than or equal to, and the graph looks like this. Okay, so that is the case number 1 with the less than sign. Let's look at case number 2. Greater than. Okay, I know I spelled that one wrong, but intentionally, guys. You see, okay? Example number 3. So here we go. We need to solve absolute value of x greater than 3. So the solution to the given inequality will be set to all the points that are more than 3 units away from 0. Okay, so keep that in mind. This one means more than 3 units away from 0. So let's look at the number line. Let's mark our 0 right here. In the middle, like a boss. Jefe, right? And then the 3 more than 3 units away from 0. So let's see, 1, 2, 3, and it say more than. So I can take like 3.1, 3.5, 4, 6, 100, right? So anything to this direction right here. So 4, 5, 6, 7, 8, 9, 10, and so on and so on and so on. So that is why we are going to take all the number on that side. And similarly, like we're talking about absolute value of x, right? So that's the distance also from 0 to the left, to either direction. Okay, it has to be more than 3 units away. So it cannot equal to 3. It can be -3.1, -4, -5, -100. Anything to the left, basically to the left of -3, will be smaller than -3. Yeah, and away from 0, more than 3 units away from 0. So basically, you are going to take all the x value that to the left of -3, right? So at -3, because this one is only greater than, so we're going to have the open dot to indicate that it's not included, okay? So we're going to put open dot at 3, and open dot at -3 to indicate that it's going to that side, and 3 and -3 are not part of the solution. Okay, so how do we represent this algebraically? So because this one is to the left of -3, it's going to have all the number that's smaller than 3, smaller than -3. Okay, so remember less than, like this, mean to the left. Okay, point to the left mean less than, point to the left mean less than, point to the left mean less than. Clear? Point to the left mean less than, point to the right mean greater than. Yep, point to the right, the number get bigger, so we have greater than. So how we gonna represent this, you ask? X gonna be less than -3 because to the left of -3, and the other side we have X is greater than 3 because, including all the number the bigger than 3. So as we can see right here, X is being pulled to two different directions. So you cannot be less than -3 and greater than 3 at the same time, right? That would be crazy. So we're going to be using the or. So either X less than -3 to the left of -3 or to the right of 3 to be solution, right? So they cannot be, you cannot combine these two, okay? Because they are not at the same place on the same interval. Cool? X cannot be at the same place on the same interval. So we are going to go ahead and conclude. The pattern for greater than absolute value inequalities always hold, and always, okay? Given the inequality f of x, absolute value of x greater than a, the solution will always start by splitting the inequality into two pieces. X have to be less than -a, or x have to be greater than a. All right, so we are going to go ahead and take a look at how the graph looks like, represented on the number line, and then write our final answer. Okay, so x minus 4 is greater than 3. Let me split my screen so that your guy can see how I type it in. Let me see. All right, let me go ahead and close this one. Use a keypad. Absolute value is right here. Oh, miss, don't forget something, the y plus. Don't forget the y plus, okay, guys? To see the whole graph, to see the shape. Otherwise, it's just gonna show you the two lines, okay? Even though it's shaded correctly, but it's just gonna, it doesn't show you the parent function, basically, the shape, okay? X minus 4. And then come outside, put a greater than 3. Boom. Oh, what you can see right here, right? As you can see, the graph is not shaded in the middle anymore. This time it's shaded away, right? It's nothing, it's empty between 1 and 7. So it's shaded outside. It's shaded outside. Okay, so to the left of 1 and to the right of 7. You see that? 0, -5, -10, all of these are less than 1. And the graph is dotted, as you can see. And at 7, all the x value is gonna be on the right side of 7. So we can go ahead and copy the graph. Again, we're gonna start with the two special points. Two special point, that is 1 and 7. X equal 1, x equal 7. Oh, what's going on here? The graph has gone crazy. Oh. Where am I? Okay, right here. Clear it out. We're going to put the two numbers. That is 1. And it's open circle because it's just going to be open like that. So we have 1 and 7. And it's staying away from 1. to the left of 1. So to this direction. And to the right of 7. To the left means less than, and to the right means greater than. Again, they cannot be at the same time on the same interval. So it's going to be an or, okay? Either less than 1, like any point right here, or it's going to be greater than 7. Cannot be both. So you got to put or. You cannot combine them, okay? Every time you see the greater than sign, add your inequality here. Greater than, that means one thing and one thing done only. That is your answer. We're gonna have or. Okay, either this or that, and it's gonna split them out in 2 different directions. Let's continue with the second example. Absolute value of 4x minus 2 greater than or equals 10. Absolute value of 4x minus 2 greater than or equal to 10. So again, we are going to start with our graph. All right, so we are going to put y plus to see the whole graph. And then we are going to put absolute value for x minus 2, what else? Greater than or equal to 10. Boom. As you can see right here, we're looking for the x-intercept and the x-intercept first in, right? We have -2 and 3. And the shaded part is to the left of -2, like this. You can see that, right? And then to the right of x equal 3. All right, so we are going to represent that on our own graph. Okay, and write our final answer. So let's go ahead. Right here, we have the greater than or equal to. Wherever that you see the equal to mean a closed dot, okay? A closed circle or the closed dot. So it filled in like that. More ink, more ink. So here we're gonna mark the 2 numbers. I bet you forgot the 2 numbers already. Let's look. -2 and 3. -2 and 3. We are going to mark them, of course, with the circle, the closed circle, okay? So right here, closed circle of -2 and closed circle at 3. They are both go to the left, like they're pulling away. So we are going to have them to the left of -2 and to the right of +3. So when you shade it, okay? So when you do it, you shade it out. Shade it. So to the left of -2 mean x have to be less than -2. And of course, because this one have equals, we are going to include the equals as well. Okay? That means -2 is a part of the solution. Hence, close dot. Same thing with the +3. +3 is included, but it's to the right side. So if it's to the right side, look at the direction of the arrow. Oh, does anybody see that? If the arrow to the right is have greater than, if the arrow to the left it have less than. What? Okay, let's continue. We are going to have that one is x gonna be greater than or equal to 3. And of course, they cannot be combined. They cannot be on the interval at the same time. So we're gonna use in or. So anything that with the greater than is greater, okay? Or. All right. I know this is a new topic and some of you might have struggled, but I encourage you to keep trying and never give up, okay? You are fantastic. You are the best student and you can learn this. You have the ability, right? You can learn and you can improve. And let's keep going. You never stop, okay? You only fail if you stop trying. So keep going, my students.